All right, let's further talk about the fundamental theorem of algebra. I gave you guys that example on the previous slide that had a quadratic that did not touch the x-axis. Class, what's the degree of this graph?
2.
The degree is 2. And how many reals does it have? It has 0 reals because it doesn't touch the x-axis. Therefore, how many imaginaries do you have? You have 2. What this implies is that imaginary roots come in pairs. So from this example, I'm proving to you that imaginary roots come in pairs. Because we says it doesn't touch the x-axis, but my degree is 2, so I'm trying to figure out where are the other zeros. It must be imaginary. So in this example, it says, well, before we get to the examples, let's draw a picture. Pairs is how many? Let's draw 2 stick figures, you and your best friend. If one of you is called A plus BI, then the other person must be called A minus BI. Do you guys remember this? It's the conjugate. Let's circle that. Conjugate. Okay? Tin can's gonna fall if I push this up anymore. Alright, so let's do this example now. If 3 minus 2i and 5i are roots of a polynomial equation, what are the other roots? So, let's review back here. The first part is the real, and the second part is the imaginary. So I have 3 minus 2i. Class, what's its conjugate? This would be a plus. So it's, where are the other roots? What's its pair? 3 plus 2i. Let's write this one. Now this one only has 5i. They call this a pure imaginary. What's its real then? There's no number here. 0. And question, is 5i positive or negative? Positive. So what would its conjugate be? Its conjugate pair? Negative 5i. And you don't need to write the 0, do you? But if you do need to, it can help you understand. So what are the other roots? The other roots are 3 plus 2i and negative 5i.